Hello everyone, I'm Mizanur Rahman Joel from Missouri SNT. Today I'll present a paper explaining the unseen multimodal vision language reasoning for situational awareness in underground mine disasters, where our goal is to generate useful natural language explanations of underground mine post-disaster scenes to support situational awareness, meaning a first responder can quickly understand what is happening, where hazards are, and what actions may be needed. Now, underground mine disasters often involve darkness, smoke, debris, and collapse, which can severely obscure vision and make scene understandings difficult. In this setting, detection alone is not enough. Responders need concise, situation-relevant explanations that summarize hazards and context. Our key challenge is generating those explanations when visual evidence is degraded, while still keeping the description grounded in what the model actually sees. We introduce multimodal disaster situation explainer, a visual language framework where our main contribution are segmentation, our dual pathway encoding that fuses global and region specific embeddings, context our cross attention to better align visual evidence with task use, and resource efficient adaptation with LoRa to reduce training cost. We also curated a domain-based dataset undergone mine disaster data with 300 images and 5 captions per image that we are going to talk later on. Here's how MDSE works end to end. First, we apply feature enhancement to improve low light and noisy images using the standard enhancement operation. We apply a sequential enhancement pipeline which includes multi-exposure fusion, tone mapping, contrast enhancement, white balance correction, and saturation adjustments so the vision encoder receives clearer structure in low light and noisy conditions. Next, we use segmenting model as an offline tool to generate region of interest mask. Even for dark or smoke obscure scene, this helps isolate critical objects and regions such as equipment, tunnel walls, hazards, or potential victims. Then comes our dual pathway encoding. A clip VIT encodes the enhanced full image for global context and the masked region for localized evidence. These two embeddings are fused with learnable projection to produce a richer representation that preserves both scene level context and fine-grained cues. We adapt a blip to cue format to make cross-attention context aware by injecting external context like scene types or task cues into the attention computation, so the model prioritizes the most relevant visual evidence during generation. Finally, we adopt generation efficiently using LoRa on the cue form and the LLM head to produce the final explanation text. To evaluate in-domain performance, we curated underground mine disaster and underground disaster image caption dataset with 300 images and 5 captions each. We curated images via keyword-based web search and supplemented them with visual realistic underground disaster scenes from films, then standardized pre-processing and resizing to 224 cross 224. This dataset enables training and rigorous evaluation of underground disaster captioning. The intent is to capture scene elements that matter for response, such as structural damage, debris, block passages, and potential hazards. So models are evaluated on description that reflected operational needs. On captioning evaluation, MDSE achieves the best scores on UMD and the Chinese news dataset among the baselines we tested, showing that these design choices help in difficult degraded scenes. On underground mine disaster, MDC achieves about 70% cider and 53% spice scores, outperforming strong baselines including DIP 2.5. We also test generalization via image text retrieval on Coco captions. MDC reaches for retrieval score 1 about 88%, and for Flickr 30K it reaches about 98%. Also for the incidents on million dataset it reaches the highest mean average precision against all baselines. Qualitatively, what MDC adds is the ability to retain subtle cues, for example, blocked passages or structural damage that are easy to miss when visibility is poor. Because we combine some guided regions with global context, we also say that context or attention improves relational detail quality, reflected in stronger semantic quality. We also run evaluation to understand what drives the gains. The biggest drops come from removing the dual pathway fusion or removing SAM-based region proposal, which confirms that combining global context with localized segmentation-guided evidence is crucial. Disabling context across attention reduces relational detail quality, while removing the feature enhancement yields a smaller decline. To conclude, MDSE generates more detailed situation-relevant explanation for underground disaster scenes than strong baselines, and the segmentation-aware dual pathway is a key driver. For future work, will extend from RGB only to LiDAR plus thermal plus gas modality fusion for situation awareness when visibility fails. Thank you.